So let's start a brand new chapter here. We're going to start working on a new section of the course called Polynomial Functions, and this is part one. We are going to work in section 5.2 of the text first, so we won't get to section 5.1 till later. We're going to start off in 5.2. So a polynomial function of degree n is a function that can be written in the form p of x equals an x to the n plus an minus 1 x to the n minus 1 plus dot 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 plus a1x plus a0, where n is a positive integer and a0, a1 to an are real numbers with an different from 0. Now, that's quite a mouthful of a definition, and we will focus on examples that will bring this definition to life a little bit. A0, A1 to AN are called the coefficients of P. AN is called the leading coefficient. AN is the coefficient of the highest power of x appearing. A0 is called the constant coefficient. A0 is the only term that has no variable factor, right? It's just a number added on by itself. So let's look at a few examples of polynomials and polynomial functions in particular here. And so the first example I write as p of x equals 3x to the fourth plus 2x cubed minus 5x squared plus 3x minus 8. So this has quite a few terms to it. Each term is of the form a number times x to a power. So those numbers in front, 3, 2, negative 5, 3, negative 8, those are the coefficients. 3 is the leading coefficient. Negative 8 is the constant coefficient. And we say this particular polynomial, I'd like to write this down, is of degree 4. The degree is the highest power of x appearing. Example 2, x to the third minus 3x squared plus 9, or x cubed minus 3x squared plus 9. That's a degree 3 polynomial. Sometimes we're going to call those cubic polynomials for short. Those have a special name. Number 3, p of x equals x to the eighth. That's called a polynomial even though it has just one term, so it's a little surprising because the word polynomial actually means many terms, but it just makes sense in math to allow even a single term like x to the eighth to fall into the same category of functions. So we will call x to the eighth all by itself a polynomial. That's a polynomial of degree 8. And p of x equals x squared minus 6x plus 3, example 4, is a quadratic function. All quadratic functions are polynomials, and by the way, they are all of degree 2. Number 5, p of x equals 2x plus 1. That's actually a linear function. All linear functions are polynomials, and we say they are all of degree 1. So a fancy way to refer to a linear function would be to say it's a degree 1 polynomial. Now, a good way to recognize if you understand what a polynomial is to be able to spot functions that are not polynomials. So here are some examples of functions that are not polynomials. Now, it has nothing to do with whether I write f of x or p of x. I could have called each one of my polynomial examples f of x if I wanted to. There's no rule about having to use the letter p or f. Really, you can use either letter. In fact, we're usually going to just use the letter f for polynomials. So it isn't the function name that tells us, it's the function expression. F of x equals 1 over x is not a polynomial because there's a variable in the denominator. And you can never have the variable x in the denominator of a polynomial. Number 2, f of x equals 3x to the 1/2 plus 5. Here the problem is the exponent of 1/2. In polynomials, the exponents are always positive integers. So we never have fractional exponents. And in fact, that x to the 1/2 stands for a square root, right? You would never have a square root of x in a polynomial function. And number 3, another example that is not a polynomial, is the function f of x equals x squared plus 2x plus 1 over x squared minus 16. Now, the problem here is we have a variable in the denominator, so right away that's a warning sign, not a polynomial. But when you look at this function, you could say the numerator is a polynomial, the denominator is a polynomial. So it's a fraction where the numerator and denominator are polynomials. That's a special kind of function we're going to study later in this chapter. It's called a rational function. But not for now. Right now we focus on polynomials. So I'm going to stop this introductory video here, and we'll start working on some examples in the next portion.